Hello there, my name is CieranBayley. Can I welcome you to my YouTube video for my final year project. My project title is a pumped hydro storage hardware in a loop system with MATLAB. Fundamentally, what I've got in front of me here is I've got the PC here, which runs the MATLAB software. I've then got my PCB, which you can see in here. So the PCB consists of two parts. There's the PCB which I made, and there's, if you look just beneath it, you can see the Arduino just beneath it. So the PCB that I've made acts as a shield and directly interconnects to the Arduino. As we can see here, there's a cable that runs from here round and off to the generator here. So this is the turbine which has been used. As we can see here, the water wheel in here, where the fluid, the water passes through the nozzle here, round, and then vents, and then fills the low level tank, and obviously the cable then takes the electrical characteristics back to the Arduino. So during the design and the manufacture of this project, I've made these PCBs. So these PCBs were designed in schematic form with fritzing. They then went to Euro circuits to be manufactured. Now I've got some spares here. So these are the spares, and I ordered these just in case there was a failure or some sort of fault with it that I then may have required them. This one here is one that's complete, and the key components are obviously these two relays here, one to control the motor and one to control the solenoid. We can see the LEDs here. One controls the low level. One of them, they're illuminated when the float switches are open or closed. Here we've got a set of resistors, but obviously we've got the hall sensors here for current detection, and the screw terminals are here as well to allow the interconnection between the PCB and the other elements. They took a lot of time to solder. As described, I need to use the MATLAB software in order to control the system. So what I'm going to do now, as you can see here, this is the code which has been programmed. Now what I'm going to do is I'm going to run this software. Here we have the GUI. So this is the interface between operator and the code itself. Let me draw your attention to the USB. So there's a USB connection from the Arduino, which goes around the back of the PC, this cable here, and into the PC there. So this allows me to then communicate with the hardware. So now, as we can see here, the Arduino is in the non-connected position. If I press this button here, hopefully it should connect. Here we go. Just change state to identify the fact the Arduino is now connected. You can also see here that the status of the float switch in the high level tank has now changed to green. Now this means that the float switch is now closed. As we can see here, the orange LED is illuminated. We've got the red LED on here, which indicates the fact there's power to the Arduino. This is the low level switch here, LED. So now what I'm going to do is, and now I've got the option to disconnect it as well. So when I press disconnect, the Arduino now changes state to non-connected. There's a slight bug in the software, so now when I press connect again, it produces this error message. I haven't found a mechanism to fix that for the time being. So what I tend to do is I'll run the software again. So again, we're in the non-connected position, and obviously both the float switches are in the red position, which means they're both open. So now when I press connect, here we go. You can now see that the Arduino is connected. So the system works in two cycles. We've got a generation cycle, i.e. when the hardware detects the fact that a float switch is closed, it then gives me the ability to either run the pump cycle or the generation cycle. The generation cycle will only run when the high level tank is in the closed position. Then it will let the water through, pass the turbine to then generate electricity. If, for example, we're running this cycle and the high level tank becomes dry, the switch will then open and the cycle will cease. If I wish to run the pump, the float switch needs to be closed, i.e. there's water inside that tank in order so the pump wouldn't run dry when it pumps the water from the low level tank to the high level tank. In its current position here, we can see the float switch is in the open position. Therefore the pump cycle will not run. As we've got the generator switch closed, I can now start the generation cycle. Here we can see I've pressed start for the generator position, and now we can just see that it's beginning to level off and gain a bit of a steady state. So here obviously we can see here we've got time against power here, and we can see some minor variations as the time increases. Now we can see here that axes have just changed in order to show the fact that these variations are relatively small. I'll let that run for a few more seconds. Just to talk you through the menus up here. Settings, the system also will calculate the motor power as well based upon the system voltage. So here I've got the ability to change it from 14, I can have it to 10 depending upon the main supply that is operating. I've also got the option to exit, plus I've got the ability to export my plot to another media. So now what I'm going to do is I'm going to go to the generator and I'm going to operate the generator by hand like this. We can now see the plot is picking up the generation. You can see here values change. Now if I stop, you can see the graph recover. So now if I select stop generator, we can see here the graph and the system immediately halts. Now I can go to export plot, and now I have the ability to save this file, say as plot 1, then it can be saved. At the minute it's saved as a text file, and it saves in that folder there. Now let me just show you. Now what I'm going to do is I'm going to remove the short or the high level float switch. You see the light go off there? So the LED. Just going to remove the short there. We can immediately see the LED is extinguished. I'll show you that on. We can see the GUI respond as well. So now if I put that short on there, see the LED and LED's illuminated there, plus the green light was on. Here as well for the low level switch. Thank you very much for watching. I hope this was of interest to you.